So hopefully quite a quick video, this one. We're going to look at alloys in this video. I say there's not a lot to know, but it does come up surprisingly often, so it's certainly worth knowing about these. Alloys, what are they? In their simplest term, they are a mixture of metals. A mixture of metals. So that's a very quick answer there. And they really are as simple as that. You can make an alloy very simply. You simply take the two metals, because you're going to have a mixture of metals, so you need at least two. And take the two metals, you're going to heat them up and melt them so they're a liquid. Pour one into the other, stir them up, and let them set. And then you have an alloy, you have a mixture of metals. Why do we do it? With simple reason, it improves the metal's properties. Normally it makes the metal stronger, although we can alloy for different reasons as well, like prevention of corrosion. But making the metal stronger is probably one of the main reasons. So why does it make the metal stronger? To answer that, we need to think about the structure of the metal. So we've got this exercise here now. It says complete the following boxes. The first one shows the structure of a pure metal. Complete this box with metal ions that are the same size. So here's our pure metal. Now all the metal ions of one particular metal are the same size. So we need to draw these ions as balls. Touching each other, next to each other, and hopefully roughly the same size, but I'm notoriously bad at these diagrams, but we'll try our best. So I've got a row there. You can fill the whole box. I'm not going to just now in the interests of time. Now we start the next row. We'll start it above, so I'm going to put this next metal ion in kind of like the hole, the indentation, if you like, made by the ones beneath. And we're going to end up with kind of like a bricks in a wall structure where they are offset slightly. So the next row is going to be above the first row, like so. And we're going to have all these ions like this, and I'll try and make them same size, try and make them touching, although I've kind of missed there, but try and imagine they are touching. And now let's just do one more row. As I said, I'm not great personally at drawing these. I'm sure you can do a better job. There we go. Right, so that's the pure metal. Now, the alloy. Now, you'll notice down here I've done a few more. I've done 4 the same size as they were here, but we've got a mixture this time. We've got another metal ion in here, and we've drawn this one much bigger. Now, this is a mixture. Okay, so we're going to have a complete random arrangement of big and little ones. With the pure metal, everything was neatly arranged. It was a regular arrangement, whereas now this is a mixture. So in the mixture, we don't have a regular arrangement. We have a random arrangement. So let's have a random arrangement of some big and some little, and we'll fill this box like so with big and little. And you'll notice the arrangement is now a mess. Okay, there's no regularity to this arrangement because the big ions, they stop that regular arrangement, like so. So why is the pure metal weaker and the alloy stronger? Well, imagine something's going to come along and give these atoms a force is going to come along and trying to shove these atoms along. I'll use my finger there to show that. So imagine my finger is trying to move these ions here along. If I poke them this end, well, there's nothing to stop these ions moving along in the pure metal because they're all the same size. The ions, when subjected to a force, simply slide along because I'll just push along. There's nothing to keep them in place. Whereas if I do the same here, then push this one, then suddenly there's a big one here. And that big one there is locking into the different layers. This big one here locks into this bottom layer. So if I shove that one will move along, yes, but it hits this one then suddenly hits the one beneath it, hits the one next to it there, and hits the one above it eventually. So the big ions lock the structure in place. They prevent the ions sliding. So, in which box, let's fill this one in now. In which box above would the metal ions find it easier to slide? Answer the pure metal. The metal ions in the pure metal slide past each other. And that's important. Slide past, wrong past. That's better. Slide past each other. This makes it weaker. Now the alloy, in the alloy, the bigger ions prevent the metal ions from sliding. This makes alloys much stronger. Okay, so alloys are stronger because the big ions prevent the ions from sliding past each other. Which is stronger, the pure metal or the alloy? We've said that already, haven't we? The alloy is much stronger. Now, probably the most common alloy is steel. What is steel? Steel is a mixture, is an alloy, so it's a mixture of iron and the most common form of steel is a mixture of iron and carbon. Okay, carbon shows some metallic properties. I've said alloys are a mixture of metals, so that's it's kind of unusual to have carbon, I suppose, as an alloying atom, but that is what steel mainly is. I say there are other alloys of steel. Carbon steel is the most common, but stainless steel, for example, is a mixture of iron and chromium, and some molybdenum as well. But mainly it's chromium and iron. So steel is a mixture of iron and carbon. Why do we turn iron into steel to use it? Steel is much stronger than iron, and that's the reason we do that.